Here's an example of dividing rational expressions. Dividing rational expressions is just like dividing fractions. The rule is to keep that first rational expression the same, change division to multiplication, and flip over this second one. You multiply by the reciprocal. So I'll rewrite the problem and then we'll factor, because it's going to be a multiplication problem just like the previous example. So if I rewrite it, I'll factor in a minute. 7x minus 7, and this first rational expression stays the same, x squared plus 5x plus 6. Okay, we're going to change division to multiplication. Let's flip over this second rational expression. So my numerator now is x squared plus 3x plus 2. My denominator now is 14 14x squared minus 14. Alright, so now it's just a multiplication problem, and remember that we want to factor everything first. If we look at the numerator of my first rational expression, you can pull out a greatest common factor of 7. Looking at the denominator, that's a trinomial, lead coefficient 1. Do the reverse FOIL method, x squared will split to x and x. Factors of 6 that add up to 5, plus 3, and plus 2. Alright, over here, this numerator, I need to factor, it's a trinomial, lead coefficient 1. So the x squared will split to x and x. The 2 has to split to 2 and 1. They're both positive. If you multiply the outsides, you'll get 1x. The inside's 2x. So if you add them together, you'll get 3x. And this denominator, look, if I pull a 14 out, let me do it right here. I'll have x squared minus 1 with a 14 on the outside. So you can see that this is a difference of squares. So my 14 will be out front. The x squared minus 1 factors to x plus 1 times x minus 1. Now, this is just a multiplication problem, and we've factored everything, so I can cancel what's common, top and bottom. The x minus 1s are common. How about x plus 1 and x plus 1? How about my x plus 2s? Those will cancel as well. And let's do the 7 and the 14. 7 goes into 14 2 times. Alright, look at that numerator. Remember when I was doing this before, when you factor or when you cancel things top and bottom, like the 7 with the 14, there's actually a 1 left in there. 7 goes into 7 once, 7 goes into 14 twice. With the x plus 1s, those are 1s left over. X minus 1, x minus 1. They matched, so we canceled them. There were actually 1s there. So now you can see what's left in that numerator. If you multiply all those 1s together, you have to remember there's a 1 that's going to be left up there. Some students, they sort of forget it, and they think the answer is just 2 times a quantity, x plus 3. But that has to stay in your denominator. So your answer is 1 over 2 times the quantity, x plus 3.